wait, just have a few more people taking their seats and we'll get started here. Good morning, I'm Liza Lister from AGU, and I am happy to welcome our 11 o'clock press conference, NOAA's 2024 Arctic Report Card. We're thrilled to have them back. Our panelists are going to give you about 20 minutes of introduction, and then we'll take Q&A from our audience here in Washington and also online. But first, to get us started, I'd like to introduce NOAA's Administrator, Dr. Rick Spinrad.
Thank you, Liza. I appreciate that. I'm going to start by going off script. This is my last opportunity to lead off the Arctic Report Card. I've done it 4 years in a row, but I want to call out somebody in the audience without whom we would not be here, and that is the individual who 19 years ago said we need to be doing something on a regular basis to provide a longitudinal perspective, and that is Dr. Jim Overland from the Pacific Marine Environmental Lab. Thank you, Jim. So, as I said, this is the 19th year, and this report card stitches together the work of 97 scientists and experts from 11 countries committed to monitoring and understanding the Arctic. It's an international collaboration that tells the story of a sustained environmental change in one of the Earth's most sensitive regions. AGU's work is vital to the scientific community, governments, industries, and communities, and our partnership strengthens our own NOAA scientific mission. Thank you all for being here today as we share these vital findings. This year's report paints a clear and urgent picture of the Arctic's evolving conditions. The Arctic continues to warm faster than the global average. This is the 11th consecutive year where Arctic temperature anomalies exceeded global averages. The Arctic tundra region has shifted from being a place for carbon dioxide storage to a source that, because of circumpolar wildfires, is releasing more carbon dioxide into the atmosphere. Winters are now warmer and wetter, and we're seeing ecosystem changes, including declining numbers of caribou. The region's vulnerability to warming is a stark reminder that we are seeing impacts of warming now in real time in the Arctic, and it's a call to action. This year, more than ever, we see the strong demand from communities for long-term monitoring and localized climate services, as well as Alaska's strategic importance in the region. NOAA is rising to the challenge, providing more resources and tools to support adaptation. This past year at NOAA, we've invested through the Bipartisan Infrastructure Law and the Inflation Reduction Act to strengthen Arctic resilience and research capabilities through projects including the expansion of our ocean observing systems, working with the Alaska Native Tribal Health Consortium on climate adaptation, enhancement of fish passage and habitat restoration, marine debris removal, and development of what we call climate-ready tools. This funding supports critical partnerships with Alaska Native tribes, academic institutions, and local organizations to improve monitoring, data collection, and community-led climate resilience initiatives. These resources complement and enhance NOAA's ongoing work in the Arctic. However, we know that the scale and pace of change in the Arctic region demands sustained and increased investment as communities and ecosystems face unprecedented transformation. A critical component of our work in the Arctic involves strengthening our operational capabilities in polar regions. This year, NOAA's Arctic Action Team analyzed scientific requirements for NOAA missions aboard U.S. Coast Guard icebreakers. This work exemplifies the kind of interagency collaboration needed for effective Arctic operations, and our findings inform the Coast Guard's Polar Security Cutter program and ensure that future icebreaker capabilities align with critical scientific needs in that changing Arctic. The importance of Arctic infrastructure cannot be overstated. As activities in the Arctic increase, supporting infrastructure becomes ever more essential. Investments in ports, in piers, represent national assets crucial for maintaining U.S. scientific leadership and observational capabilities. At NOAA, we recognize that strong climate solutions demand indigenous and local knowledge and collaboration from the get-go. with tribes and communities. One of my goals as administrator has been to establish two-way lines of communication in every corner of the country so we can get resources into communities and hear from those with a local ear to the ground. Equity is in the DNA of all of our initiatives, investments, and resources. This year, we released NOAA's first equity framework and equitable climate services action plan. These are just some of our recent efforts, and NOAA will continue to increase our activities in the region in recognition of its deep, deep importance to pressing climate and security issues. Now, before I hand the microphone back to Liza and our expert panel, who will dive into specific key findings, we have a short highlights video to kick off the presentation of the 2024 Arctic Report Card.
The Arctic is an ecosystem in transition, and adaptation to a warmer Arctic is essential to the survival and resilience of its plants and wildlife, and the well-being of the communities that depend on them. Transformation is especially clear on the Arctic tundra. The tundra has absorbed and stored carbon in frozen soil for millennia, but wildfires across warming permafrost regions are increasing and tipping the scales, resulting in the release of carbon back into the atmosphere, accelerating human-caused climate change. Another of the region's most defining characteristics, sea ice, has served as a bellwether of the Arctic's shift to a new environmental state, particularly over the last 2 decades. And Arctic surface air temperatures continue to rise, with 2024 being the second warmest year on record. In August, record-breaking heat waves baked northern Alaskan and Canadian communities. But these changes aren't uniform. In the Eurasian Arctic, sea surface temperatures were unusually high, while temperatures in the Pacific Arctic were much lower. In parts of the Canadian Arctic and Siberia, an extremely dry summer stood in stark contrast to heavy precipitation over much of Alaska and Scandinavia. And across the Arctic, winter snow accumulation was above average, but the length of the snow season contrasted sharply by region. For parts of the Canadian Arctic, a late onset of snow and early spring melt resulted in the shortest snow season in 26 years. Despite challenges, the threatened ringed seal populations in the Pacific Arctic region are persevering, even though their primary food source, Arctic cod, is becoming less available as ocean waters warm. But as the sea ice, where females nurse their pups, becomes less stable in spring and recedes earlier, the seal's future remains uncertain. Unlike ice seals, many North American migratory caribou are facing severe population declines, plummeting by 65% overall in recent decades. Though small coastal caribou populations have recently grown or remained stable, rapid declines in large inland populations are a serious concern for local communities. The increase in freezing rain and rain-on-snow events makes it difficult for foraging caribou to access food, and warmer temperatures allow taller shrubs to crowd the lichen the caribou depend on. As the Arctic warms, Indigenous peoples work to preserve and evolve their cultural practices, demonstrating resilience and adaptability in the face of extreme environmental transformations. But Arctic changes have worldwide impacts, and global attention is critical to reduce risks into the future and support successful adaptation in the Arctic and beyond.
Here today to talk with us more about the report card, the lead editor of the 2024 Arctic Report Card, Dr. Twyla Moon from the National Snow and Ice Data Center at the University of Colorado. We also have the lead author of the Terrestrial Snow chapter, Dr. Lawrence Mudrick from the Environment and Climate Change Canada, Dr. Brendan Rogers from Woodwell Climate Research Center, is an author on the Terrestrial Carbon Cycling chapter, and Lori Quakenbush, an author of the chapter on ice seals. And I'll pass it over to Dr. Moon to get us started.
Thank you, Liza. Good morning. I'm Twyla Moon with the National Snow and Ice Data Center, part of the University of Colorado Boulder's Cooperative Institute for Research in Environmental Sciences. And on behalf of my fellow Arctic Report Card editors, Matthew Druckenmiller and Rick Toman, and our coordinating editor, Cynthia Garcia, I want to express our gratitude to the many contributors to this year's report. I also want to thank the Arctic Research Program in NOAA's Global Ocean Monitoring and Observing Program for supporting the Arctic Report Card and the teams working to produce outstanding graphics, video, and web pages. Along with Dr. Spinrad, I'm honored to be here with 3 of this year's authors who will update you on key headlines from the report card: Lawrence Mudrick, Lori Quakenbush, and Brendan Rogers. We also have additional authors both in the room and online who can address questions during the Q&A. The Arctic Report Card is truly an international collaboration, bringing forward observations made possible by dozens of researchers working together. We have also been increasing representation within the report from Arctic Indigenous peoples and other Arctic residents. This diverse perspective is essential to understanding the scale and complexity of the physical and ecological changes observed across the Arctic and their implications for societies within Alaska, the Arctic, and beyond. Each year, the report card monitors this rapidly evolving system through 8 vital signs which are interconnected and influence each other, assessing long-term trends, and this year's events within these vital signs provides a view into the state of the Arctic system. We also provide less frequent updates on the other parts of the Arctic system through the indicators, which this year examine caribou, ice seals, and the storage and release of carbon and heat-trapping gases in the Arctic landscape. Newsworthy and broader implications are discussed within the frostbites. This year's frostbite highlights the incredibly important role of Arctic Indigenous hunters and harvesters who have been researching the Arctic system since time immemorial. Supporting their work and way of life is supporting Arctic research. An important starting point for the Arctic Report Card is recognizing that human-caused warming of our planet is amplified in the Arctic. The Arctic continues to warm more quickly than the globe overall, and the last 9 years in the Arctic are the 9 warmest on record. This year, an early August heat wave set all-time record daily temperatures in several northern Alaska and Canadian communities. These consistent extremes are changing the experience of living in the Arctic. Conditions that would have been considered extreme in the past are now becoming regular occurrences. As we turn to the sea, most Arctic Ocean marginal seas were approximately 3 to 7 degrees Fahrenheit or 2 to 4 degrees Celsius warmer in August 2024 than the 1991 to 2020 August average temperatures that we compare them to. Since 1982, Arctic Ocean regions that are ice-free in August show multi-decadal warming trends. Average sea surface temperature has increased by roughly 0.5 degree Fahrenheit or 1/3 of a degree Celsius per decade. This is a remarkable increase in temperature, especially for waters that are meant to form substantial sea ice on the ocean surface each year. Ocean warming is both a cause and effect of what is now a decades-long decline in sea ice extent. The last 18 September minimum sea ice extents are the 18 lowest within the last 45 years record. Recent minimum sea ice extent is only about 50% of what it was in the 1980s. The extent of thicker, older ice, which is an important habitat for many species, has remained even lower since 2007. The area covered by thicker, older sea ice has decreased by more than 95% since the 1980s. The Northwest Passage, north of Canada, had record low sea ice this summer, and the Northern Sea Route that passes north of Russia saw record 2024 ship traffic. The multi-decadal observations for many vital signs suggest that the Arctic exists now within a new regime, in which conditions year after year are substantially different than just a couple of decades ago. Yet, climate change is not bringing about a new normal. Instead, climate change is bringing ongoing and rapid change. The change we observe in the Arctic is not only rapid, they can also be complex changes. Stark regional differences can bring very different weather experiences to neighboring communities during the same season, or a single location can experience big swings in weather from one season to the next. These dramatic differences are making it difficult for communities to plan, and they create safety issues for people who are used to more stable ice, snow, and temperature for hunting, fishing, traveling, and other activities. One example of a dramatic swing this year comes from Greenland. Despite the Arctic overall experiencing the second warmest year on record, weather patterns brought cooler conditions to western Greenland during the summer melt season. This was one factor leading to a year of modest ice loss for the Greenland ice sheet. Losing roughly 55 gigatons of ice during September 2023 to August 2024, this was the lowest annual ice loss for the Greenland ice sheet since 2013. Unfortunately, however, it was still a year of overall ice loss, the 27th year in a row that Greenland has contributed to global sea level rise. Now I'll turn it over to Lawrence Mudrick, who will discuss changing precipitation patterns and snow cover across the Arctic, exploring examples of rapid change and stark regional differences.
Thank you, Twyla. Along with temperature, precipitation amounts and type are key indicators of Arctic conditions and can influence many other environmental variables across the region. Pan-Arctic precipitation from the period of autumn 2023 through summer of 2024 was well above average, and in fact, the summer of 2024 was the wettest yet in a record that extends back to 1950. The record summer conditions included above average precipitation over interior Alaska, the Canadian Arctic archipelago, and a broad region east of Greenland from the Barents Sea through northern Scandinavia. The high precipitation amounts seen during the summer are part of a trend towards a wetter Arctic. When examining long-term changes over the period from 1950 to 2024, Arctic precipitation shows a clear increasing trend that you can see on the slide. The trend is present in all seasons, with the most pronounced increases occurring during autumn and winter. Turning to snow cover, the 2023 to 2024 snow season highlights strong regional contrasts across the Arctic. Many parts of Alaska and Eurasia experienced either an early start to the snow season during the autumn of 2023 or later snowmelt during the spring of 2024. This combination led to a large region with longer than average snow season across much of Eurasia and Alaska. These can be seen on the map in the lighter colors. In contrast, over large swaths of Arctic Canada, late snow onset and early spring melt reinforced one another to result in the shortest snow season in the 26-year record. These are shown on the map in the darkest colors. While some of the regional contrasts observed in the snow season length are reflective of year-by-year differences in weather patterns, the long-term changes observed in snow cover provide clear evidence of a new Arctic regime. Over the past 15 years, Arctic snowmelt has commonly occurred on average 1 to 2 weeks earlier through May and June for both North America and Eurasia compared to the historical conditions. This earlier snowmelt is a signal of longer Arctic summers with implications for tundra greening and wildfires. Now I'll pass it to Brendan Rogers to discuss how changes in the aforementioned variables, snow, temperature, and precipitation, are affecting other things like tundra greening, wildfires, and permafrost, and how those in turn combine to affect the storage and release of carbon in the Arctic.
Thank you, Lawrence. So that concept of a new regime definitely applies to Arctic vegetation, wildfires, and especially carbon cycling. The 2024 circumpolar average greenness value, a measure of vegetation amount and photosynthesis impacted by changes such as expanding shrub cover, ranked as the second highest in the 25-year satellite record, continuing a recent sequence of high greenness values. However, this change is not uniform across the Arctic. We observed zones across the Siberian tundra that were anomalously brown, demonstrating the regional variability in Arctic vegetation changes. Carbon cycling in the Arctic is really important to understand because the region contains massive amounts of carbon in its soils, most of that locked up in permafrost, or ground that has been frozen for hundreds to thousands of years. When we think about this, it's important to note that the Arctic has acted as a carbon sink for millennia, gradually building up these large terrestrial carbon stores as plants photosynthesize, taking carbon dioxide out of the atmosphere and depositing carbon into the soil. Where microbial decomposition has historically been slow because of cold temperatures and frozen soils. However, as climate change is happening, soils warm, permafrost is thawing, and microbes are waking up, and that decomposition or emissions of carbon dioxide and methane back into the atmosphere is increasing. Long-term data across Alaska show that deep permafrost warmed up to 2.2 degrees Fahrenheit in interior Alaska over the last 40 years, but over twice that in colder parts of the state. Permafrost temperatures in 2024 were the highest on record for 9 of the 20 long-term monitoring sites in Alaska. One of the most profound visible changes, and one that has a direct impact on carbon cycling, is the intensification of wildfire across the Arctic. So wildfires combust vegetation and soil organic matter, emitting that carbon back into the atmosphere. And by removing insulating soil, they can also lead to longer-term permafrost thaw and carbon emissions. We've observed a clear multi-decadal increase in wildfires across North American permafrost regions since the mid-20th century. Last year, 2023, was the largest fire year on record due to Canadian wildfires, which burned more than twice any other year on record in Canada, and in Canada's permafrost region emitted nearly 400 million tons of carbon. So just for perspective, that's more than 2.5 times the carbon emissions from all other sectors in Canada combined, and higher than every other country's annual emissions except China, the US, India, and Russia. Wildfires are now an urgent annual concern for Arctic residents as they degrade air quality, disrupt travel and subsistence, and threaten infrastructure. The impact of climate change on Arctic carbon cycling is indeed complex. Warming temperatures tend to increase the uptake of carbon dioxide by Arctic vegetation during the summer, consistent with that greening trend I mentioned earlier, but they also generate increased net carbon dioxide emissions from soil microbes in the fall, winter, and early spring. Combined with wildfires, the permafrost region, which historically has acted as a carbon dioxide sink, has been essentially carbon dioxide neutral over the past 20 years, meaning we can't really differentiate between a net carbon dioxide source or sink. The Arctic tundra, however, which is a large expanse of treeless lands in the more northern portions of the map you're seeing, has shifted from a carbon dioxide sink to a small net source. And Arctic terrestrial ecosystems continue to emit methane, another source of carbon and powerful greenhouse gas. This transition from a carbon sink to a source is of global concern because carbon dioxide and methane are heat-trapping greenhouse gases, and societies struggle to rein in emissions and align with international climate goals. Now I'll turn it over to Lori Quakenbush to discuss how these environmental changes are affecting Arctic species.
Thank you, Brendan. Starting with the ocean, we can look at the strength of phytoplankton blooms that represent ocean primary productivity, which forms the foundation of the Arctic marine food web and are showing strong regional differences. Overall, from 2003 to 2024, phytoplankton blooms continue to increase in most Arctic regions, except for the Pacific Arctic, the Chukchi Sea, Beaufort Sea, and the Canadian archipelago. In 2024, lower than average primary productivity dominated across much of the Arctic, with the lowest values found in the East Siberian Sea, Chukchi Sea, and Beaufort Sea. In these regions, the low productivity coincided with near average or higher than average sea ice cover and delayed spring sea ice breakup. These changes matter because they tell us how much energy and food are available to sustain Arctic marine life, from tiny zooplankton to large whales. The amount of phytoplankton is sensitive to sea ice cover, ocean temperature, and nutrient availability, all of which are changing rapidly as the Arctic continues to warm. Looking higher up on the food chain, ice seal populations across the Bering and Chukchi Seas remain healthy despite dramatic long-term warming and sea ice loss within their home range. Measurements of body condition, reproduction, and pup survival are the same or better than they have been in the past. Recently, ring seal diet has shown a decrease in Arctic cod, which prefer colder water and are expected to decline in availability, and an increase in saffron cod, which prefer warmer water and are expected to become more available. This dietary shift aligns with the predictions of warmer conditions. However, no negative consequences of this change are currently evident. Therefore, although ice seals are highly adapted to sea ice, which is declining, we have not yet seen evidence that their adaptive capacities are limited by current ecological changes. Turning to the land, Arctic migratory tundra caribou numbers have decreased by 65% since a peak in the 1990s and early 2000s. Warmer weather affects caribou in summer by increasing energetic demands to avoid insects. Caribou also eat less to avoid increasing internal temperatures generated by digestion. Warmer weather in winter increases freezing rain events that cover plants in ice, making foraging more difficult for caribou. Although some smaller coastal caribou herds of the Western Arctic have seen some recovery in the last decade, large inland herds continue to decline or remain at their lowest numbers, as noted by Indigenous elders. Declining caribou herds are a critical concern for local people whose food security has been tied to these animals since time immemorial. Now I will pass to Twyla to share the response of Arctic communities to these environmental changes.
Thank you, Lori. Arctic residents are responding at the moment to changes underway, and the deep observational skills of Indigenous hunters are helping their communities to understand the changes and prepare and take action. While we can hope that many plants and animals will find pathways to adaptation, as ice seals have so far, hope is not a pathway for preparation or risk reduction. With almost all human-produced heat-trapping emissions created outside of the Arctic, Only the strongest actions to reduce these emissions will allow us to minimize risk and damage as much as possible into the future. This is true for the Arctic and the globe. Support for observations, collaboration, and adaptation is required in every scenario. In our connected Earth system, we all have a role to play to minimize risk, support adaptation, and foster collaboration. I'll now ask Liza to assist with moderating questions from the media.
Thank you, Twyla. Are you hearing me? Yes, good. So we'll open this to questions from the room and online. And raise your hand as someone just demonstrated if you want to ask a question. Please introduce yourself and your outlet when you do ask a question. And as was noted, we have many of the other chapter authors here with us in the room. Dr. Moon is going to help direct those questions to the right person. You may see them popping in on the screen as well. I see hands already. Who wants to go first? I think you were first.
Great. Hi, Zach Coleman with Politico. There's been a lot of debate lately about the usefulness of the term tipping points in the climate science literature, but this carbon source finding that you have about the Arctic, I mean, is this a tipping point? Can we call it that, or can we call it like we see it there?
Brendan, would you like to adjust the use of tipping point and the changes in Arctic?
Sure. Yeah, I think it sort of depends on what you mean by a tipping point. I guess what I would say is, you know, as I've mentioned in the remarks, that this region has acted as a carbon sink for a long time, for thousands of years. There is a concern, of course, with the amount of carbon that's stored, especially in permafrost, as climate warms, as those soils warm, that could be released. And the scientific consensus is that some of that will be released. It could be equivalent, for example, to a major greenhouse gas emitting country. And the observations and what we put in the report card, I would say, is at least consistent in many regions with that sort of transition. But, you know, whether or not you call it a tipping point, again, I think sort of depends on your definition. And I don't, from the best data and models that I've seen, I don't see a lot of evidence for tipping point-like behavior. But we still have some that we need to observations and models can improve.
It is useful to keep in mind as you're thinking about different components of the Arctic that there's different timescales of irreversibility of many of these changes, with many changes being not irreversible on hundreds or thousands of year timescales.
Thanks. I'm Alex Witze, reporter with Nature. My question is for Dr. Spinrad. You laid out investment in resources that NOAA is partnering with and providing local communities to respond to these scope of changes. But of course, we're facing a change in administration. What message do you have for local communities who NOAA has partnered with up until this point about whether or not the agency can continue to be a reliable partner?
So thank you for that question. The short answer is that we're staying on course at speed. That our intent with the investments we've made, many of which are multi-year investments, is to continue to serve these communities. We have no indication that there'll be a change in any policy associated with that kind of activity. And the bottom line is that this is the demand signal. It's not NOAA or our federal partners saying, we think we should do this. It's responding to what communities, industries, individuals are saying they need. So I have every confidence that that demand signal will sustain, and therefore it's incumbent on the federal agencies to maintain those investments.
Thanks. James Deneen with New Scientist. My question is also for Brendan. Was this shift in tundra from emissions sink to source something that was anticipated by modeling, and is it happening sooner than expected or not? And can you also quantify the size now of that emission source? And are we talking only about CO2 or also methane and CO2 equivalent when you talk about the source?
Yeah, I mean, this is Brendan. I guess I would say this has been anticipated for a while. The overall size is still relatively small, but again, I think it's that transition that we're sort of concerned about. And you know, the general pattern that we see in the data, and there have been a number of studies that have come out in the last year showing this from different approaches, is that the further north you go, you see these systems start to look more and more like CO2 sources. But even stepping back, looking at the whole permafrost region, if it's CO2 from the terrestrial ecosystems that we focused on, but there's also emissions from inland waters, there's also fires, there's emissions of methane. And when you pull all those things together, it certainly seems like that region is a source of greenhouse gas warming to the atmosphere.
Just to follow up, Brendan, when was that call made? Was that recently? Carbon source rather than saying?
Like I said, there have been a handful of studies that have come out this past year. Our work that we document and put into this chapter is looking at the 2001 to 2020 period, average conditions, and so that's what it's finding, is that the CO2 is the source. We're working on methods to be able to do this in more near real time, but that's where we are now.
Anyone else?
Marianne LaBelle from Inside Climate News. Dr. Rogers, you talked about the 200 million or so tons of carbon emitted by wildfire. So that's not the number of that you see from the Arctic, because there's uptake as well. Can you explain the difference between that emission number and what the number would be for the emission source of the tundra?
Right. Carbon cycling is complex. So wildfires, especially in boreal forests, they will emit carbon to the atmosphere, and over time those forests can regrow. What's a challenge right now is, of course, in areas with permafrost, that those fires will remove the insulating soil organic matter. That permafrost can thaw and lead to longer-term emissions. And we're just seeing this general intensification of wildfires since the mid-20th century, so that they're emitting net carbon into the atmosphere. So that's all accounted for in the estimates that we put into the report card about the tundra being a net source, so that includes wildfires, and the permafrost region being roughly CO2 neutral when you include wildfires.
More questions from reporters in the room?
Hi, Omer Irfan at Vox. Again, also for Dr. Rogers. How sensitive is this flip to some of the recent temperatures that we've seen? You know, the past 2 years have been some of the hottest on record. If we potentially see a cooler year next year, could we see this flip back in the other direction? How permanent and how robust of a flip is this in either direction?
Yeah, I would say that a lot of the community is working on trying to understand this. In some regions, we certainly see an increased sink when we see warmer temperatures, especially in the boreal zone. So if you include the entire tundra and boreal regions, some of those boreal regions have permafrost, some don't, it's still acting as a sink, and that's a really important sink. The concern is that in areas, especially further north, it looks like the plants aren't able to keep up with that. And so when we have warmer temperatures, not just during the summer, but all year round, right? So this past year has actually been a pretty large winter emissions year in a lot of the sites that we've seen. And so those emissions are coming out all year round. And there's a lot of carbon in that permafrost that could potentially be emitted to the atmosphere.
So if next year were cooler, could you potentially put that in the other direction?
It could. It sort of depends on a lot of factors. It's also the methane emissions. There's also the wildfire component. But yes, I mean, there is definitely interannual variability. What I'm reporting on here is the average condition we've seen over a 20-year period.
Hi, Chelsea with E&E News by Politico. I wanted to follow up on an earlier question that was asked about your messaging to local communities on your ability to continue your partnerships under the next administration. Wanted to apply the same question to NOAA's capabilities in general for climate monitoring in the Arctic via satellite or on-the-ground measurements, what have you. Do you have any concerns about continued funding for these kinds of capabilities under the next administration, which has in fact indicated that climate change and climate science is likely to be a lower priority? If so, any particular programs you would want to highlight, or anything for which you'd like to see more investment?
I assume that's for me.
That's for you, yes.
There's a lot, thank you for that. There is a lot to unpack there. And I think one of the things that we're trying to make sure people understand is that certainly from a NOAA perspective, we're a mission agency. And so the research that we do, the science that we do, the observations that we make are all focused on priorities of need. And that, in fact, the argument I would make is that now more than ever, the need, the requirement, the demand signal, if you will, is higher than ever before. And so, in fact, the observational capabilities in our research investments, as demonstrated by the impacts, whether it's fires, floods, drought, coastal inundation, are higher than ever. And so rather than thinking about, gee, how might we make cuts here, the argument that's incumbent on all of us, the scientific community, the federal agencies, is there's a need for these investments to increase right now. The final piece of that is we can demonstrate, and have done so through a number of studies, that the return on those investments is extraordinary, in many cases 10 to 1 in terms of protection of lives and property. And so I think the argument, rather than how do you keep from making cuts, is more how do we get more effective in making the argument that the investment is well worth it and the return is extraordinary on these kinds of research activities.
Who's next? I see hands. Going once. James?
Just another question on the flip from sink to source. You looked at the 20-year period between 2000 and 2020. Did the flip happen at some point during that period, or is it the average across that entire period? And do we know what's happened since 2020?
That is just the average across 2020, and we do see interannual variability. Even if you go back in time, you'll see some years that are sources, some years are sinks. So you sort of want to take this longer term average to really understand. In terms of the past couple years, we don't have the data to sort of say at large scale using the methods we use, but we have a lot of sites that we've looked at. And so I'm wondering if Ted Schur, who's in the room, who has worked on these sites a lot, wants to say anything about what you're seeing on the ground.
Yes, I'm Ted Schur from Northern Arizona University, worked with Brendan and others on the Arctic Carbon chapter, and I think it's important what Brendan said is that there is interannual variability, but what we're describing is a long-term 20-year trend towards this increasing source from the tundra region, so that's really important. It's sustained. So no matter what happens next year or the year after, it looks like that's going to continue. In the Arctic Report Card, we also analyzed for the first time 2024 data from Arctic carbon emissions. And we find record high emissions of CO2 and methane, primarily in the winter time, which is very interesting because it's our least sampled season. And so in places that we're hardly paying attention, we see records being set, and we think it's very important. Thank you.
Alex Witze again with Nature for Dr. Moon. Another future-looking question, which is, what are the plans for a 2025 Arctic Report Card? Like, how does that process spool out throughout the year? Has it already begun? What would be the usual time frame for that to be developed?
Yeah, 2025 will be a big event for the Arctic Report Card, as it will be our 20th Arctic Report Card. And we do begin now, just as we wrap up here, our conversations about what that looks like. We have some fun things in the works to think about how we might continue to evolve, how we get the most current data and complete data to all of those who are interested in following the Arctic Report Card and sharing its information. We do have an open Google form. We accept suggestions for topics in the Arctic Report Card from across the community, and usually it's in spring that we determine what topics will be included in each year's Arctic Report Card. You can appreciate that's a difficult decision because we haven't yet faced the summer of that year. So we do also sometimes introduce sidebars or things like that. If there's a surprising event that occurs that's important for us to cover, that we discover after we make those decisions on what will be included, for example, as indicators and frost bites. So the Arctic Report Card is a year-round effort, and we'll be thinking about the next one as soon as we wrap up this one.
Who would like to ask the next question? Online? Going once, going twice. I think I will close this Q&A session. Thank you so much to our speakers. Our next event is lunch, We hope you come back after lunch to talk with us about the Parker sauropods' next Close Encounter with the Sun at 1:30 in the roundtable room. Thank you.
Thank you. Sorry, I've got such sweaty.